In the last video, we told the story of Jiro Horikoshi and the Mitsubishi A6M Zero, the fighter that ruled the early Pacific. A machine so light, so agile, and so impossibly capable that for 6 months after Pearl Harbor, no Allied pilot who met one in the air could expect to survive the encounter on equal terms. The Zero achieved a kill ratio of 12-1. It dominated every theater it entered, and it did it by sacrificing everything that Western designers considered essential. No armor, no self-sealing fuel tanks, and no protection of any kind for the man sitting behind the engine. Every gram Horikoshi removed to make the Zero untouchable became a gram of protection its pilot did not have. That was the trade. And by mid-1942, the United States Navy understood both sides of it. They knew the Zero was better than anything they were flying. They also knew it was fragile. What they needed was a machine built on the opposite philosophy entirely. Not light, not graceful, not elegant, but heavy, fast, and armored. A machine that could absorb punishment the Zero could not survive, deliver firepower the Zero could not withstand, and bring the pilot home alive when the fight was over. The Zero was the creation of one engineer and an impossible specification. The machine that killed it was the creation of 4 men in a factory on Long Island. A founder who believed every aircraft should be built stronger than it needed to be. A factory boss who walked carrier decks to ask pilots what was getting them killed. A structural designer who insisted every component be built to twice its required strength. And a chief engineer who had designed the fastest racing planes in America and now drew the fighter that would become the most lethal carrier aircraft of the Second World War. This is the story of the Grumman F6F Hellcat and the company they called the Iron Works. The company began in a rented garage. On December 5, 1929, 6 weeks after the Wall Street crash, Grumman Aircraft Engineering Corporation was incorporated on paper. On January 2, 1930, it opened for business in an abandoned auto showroom in Baldwin, New York. The building had been used by a defunct aircraft company called Cox Clemon. The windows were broken. Dried leaves from several autumns littered the floor. The rent was cheap. That was the only thing about it that recommended the place. The founders were 5 men who had worked together at the Loaning Aircraft Engineering Corporation in New York City. Loaning built amphibious aircraft for the Navy. In 1929, Keystone Aircraft bought Loaning and moved the operation to Bristol, Pennsylvania. The 5 men refused to go. They decided to start over on Long Island instead. Leroy Randall Grumman was the leader. Born in Huntington, New York in 1895, he had studied mechanical engineering at Cornell, enlisted in the Navy during the First World War, failed a flight physical because of flat feet, been sent to pilot training at MIT anyway thanks to a clerical error, and served as a naval aviator and flight instructor. After the war, he spent a decade at Loaning, studying how to build aircraft that survived the most punishing environment in aviation: carrier decks, salt water, arrested landings, and the repeated stress of launching and recovering machines on a pitching ship at sea. Grumman understood from the beginning that a Navy airplane was not judged by how fast it flew or how tightly it turned. It was judged by whether it brought the pilot home. He mortgaged his house for $16,875 to start the company. Leon Albert Swerble, universally known as Jake, was the second founder. Born in Manhattan in 1898, the son of Latvian immigrants, he had grown up on Long Island and served as a Marine during the war. Where Grumman was quiet, cerebral, and shy, Swerble was loud, physical, and relentless. He was a factory man. He understood production flows, labor management, supply chains, and the mechanics of turning raw material into finished machines on schedule. He contributed $8,125 of his own money. His mother borrowed $6,000 more. Swerble would run the production side of Grumman for the next 30 years, and it would be his management of the factory floor that turned the Hellcat from a design into 12,000 aircraft in 3 years. William T. Schwendler was the third. Born in 1904, the son of a German immigrant, he graduated from New York University in 1924 as one of the school's first students of aeronautical engineering. Schwendler was a structural thinker. He understood loads, stresses, and the forces that tore an airplane apart in flight or on impact. At Grumman, he became the guardian of a design philosophy that would define every aircraft the company built. Build the structural components to twice the required strength. Not because the specification demanded it, but because the specification did not account for what actually happened to a Navy fighter in combat, in storms, in botched carrier landings, and in the 100 unpredictable moments that separated a machine that came home from one that did not. The three men kept the company alive through the Depression by repairing loaning amphibians, building aluminum truck bodies, and welding pontoon floats. Grumman invented a retractable landing gear mechanism demonstrated with a bent paperclip and a pencil eraser. The Navy gave them a contract, then another. In 1931, Grumman designed the FF-1, the first Navy fighter with retractable wheels and the fastest naval fighter in the world at 198 mph. The company moved to Valley Stream, then Farmingdale, then in 1937 to Bethpage, Long Island, where it purchased farmland and built a factory with its own airfield. Bethpage became the company's permanent home. In 1934, Grumman told his partners that 250 employees should be the company's absolute maximum. The accountant informed him that payroll was already at 253. Grumman accepted the information, but he never accepted the principle. He never wanted a large company. The war overruled him. The fourth man arrived in 1936. Robert Lester Hall was born in Taunton, Massachusetts in 1905, the son of a mechanical engineer. He graduated from the University of Michigan in 1927 with a degree in mechanical engineering and immediately entered the world of high-speed aircraft. He joined the Granville Brothers Aircraft Company in Springfield, Massachusetts, first as a designer, then as chief engineer and test pilot. At Granville Brothers, Hall designed the GB Model Z, one of the most famous racing airplanes ever built. The GB-Z was a radical machine, essentially a massive engine wrapped in the smallest possible airframe. A short, fat, barrel-shaped monoplane that observers said looked like a section of sewer pipe that had sprouted stubby wings. It was blindingly fast. At the 1931 National Air Races in Cleveland, Hall and another pilot flew GBs to 5 first-place trophies. The GB-Z set speed records. Jimmy Doolittle called it the sweetest ship he had ever flown. The GBs were also lethal. Their short coupling and small control surfaces made them dangerously unstable. Multiple pilots died flying them. The Granville Brothers Company went bankrupt in 1934. Hall moved on. He worked briefly at Stinson Aircraft in Dayton, Ohio, designing the Stinson Reliant. In 1936, he joined Grumman as chief engineer and chief test pilot. The combination of Hall and Schwendler created a design partnership that would produce the most consequential series of naval aircraft in American history. Schwendler provided the structural philosophy, the insistence on over-engineering every load-bearing member, and the refusal to sacrifice durability for weight savings. Hall provided the aerodynamic vision, the instinct for how an airplane should fly, and the rare willingness to personally fly the prototypes he designed. Hall would make the first flight of the F-4F Wildcat, the TBF Avenger torpedo bomber, the F6F Hellcat, and the F-8F Bearcat. He tested every machine he drew. If the aircraft could kill a pilot, Hall found out before anyone else sat in the cockpit. By the late 1930s, the four men had defined their roles. Grumman set the philosophy: build it strong, keep it simple, and make sure it works. Swerble ran the factory and maintained the relationship with the Navy that kept the contracts flowing. Schwendler ensured the structural integrity that made every Grumman aircraft tougher than the specification required. Hall designed the aircraft and flew them first. The Navy started calling the company the Iron Works. The nickname did not refer to elegance or speed. It referred to the fact that Grumman airplanes came home. The Wildcat was the machine that proved the philosophy and exposed its limits. The F-4F Wildcat was a stubby, squat, barrel-chested monoplane with folding wings, 650 caliber machine guns, armor plating behind the pilot, and self-sealing fuel tanks. It was not fast, it was not agile, it was not graceful. It was a Grumman. When the Japanese attacked Pearl Harbor on December 7, 1941, the Wildcat was the Navy's primary carrier fighter. Within weeks, it was fighting Zeros across the Pacific. The results confirmed what every American pilot already knew. The Zero was faster, it climbed faster, it turned tighter. In a traditional dogfight, the Zero won. But the Wildcat had something the Zero did not. It could take a beating and keep flying. A Zero that absorbed hits from the Wildcat's 6 heavy guns came apart or caught fire. A Wildcat that absorbed hits from the Zero's machine guns often flew home with holes in the fuselage and the pilot still breathing. Lieutenant Commander John Thack devised the Thack Weave, a two-plane defensive maneuver that exploited this disparity. Two Wildcats flew in a weaving pattern. When a Zero attacked one, the other turned into the attacker and fired. The tactic refused to play the Zero's game. At the Battle of the Coral Sea in May 1942, Wildcats shot down 14 Zeros for a loss of 10. At midway the following month, Thack's Wildcats fought outnumbered against waves of Zeros, while American dive bombers slipped through and sank 4 Japanese carriers. From August 1942 through February 1943, Marine and Navy Wildcat pilots ground down Japan's experienced aviators in a 6-month air campaign over Guadalcanal that killed the men faster than Japan could train replacements. The conditions were brutal. Henderson Field was under constant bombardment. Pilots flew multiple sorties a day in tropical heat with inadequate maintenance and limited fuel. The Zeros they faced were flown by Japan's best veterans of China and the opening campaigns who had been killing since before Pearl Harbor. The Wildcats held the field. By the end of Guadalcanal, the kill ratio had improved to nearly 7-1. The attrition of Japan's experienced pilots was invisible from the outside, but it was fatal from within. The Wildcat held the line, but Jake Swerble knew the line was not enough. Swerble had contacts throughout the Navy. He traveled to carrier decks and air stations. He talked to the men who flew the Wildcat into combat. He asked them one question over and over: "What do you need?" The pilots answered. They needed a fighter that climbed faster. "Give us something that will go upstairs faster," they said. They needed more speed, they needed more power, they needed more armor. They needed a machine that did everything the Wildcat did, but did it well enough to stop surviving the Zero and start killing it. Swerble carried those requests back to Bethpage and put them on the desks of Schwendler and Hall. The story that persists in popular history is that the United States recovered a crashed Zero from Akutan Island in the Aleutians, studied its secrets, and built the Hellcat to exploit its weaknesses. The story is dramatic, but it is also substantially wrong. On June 3, 1942, during the Japanese diversionary attack on the Aleutians, a 19-year-old pilot named Tadayoshi Koga took ground fire that severed his Zero's oil line. He attempted an emergency landing on Akutan Island. The aircraft flipped on marshy ground, and Koga was killed. The airframe survived nearly intact. American forces recovered it a month later, repaired it, and began test flights in late September. But the Hellcat was already flying. Grumman's design specifications for the XF6F1 were dated February 24, 1941, 10 months before Pearl Harbor and more than a year before Koga's crash. The Navy contract was signed on June 30, 1941. The first prototype, the XF6F1, took to the air on June 26, 1942, with Bob Hall at the controls, 3 weeks after the Dutch harbor raid and months before the Akutan Zero was even recovered. Hall flew the prototype for 25 minutes over Bethpage, Long Island. A second prototype, the XF6F3, flew on July 30th. The first production F6F3 made its maiden flight on October 4, 1942, just 2 weeks after flight testing of the Akutan Zero began in San Diego. The timeline makes the myth impossible. The Hellcat was not born from a crashed Zero. It was born from the reports of Wildcat pilots who had been fighting Zeros since December 1941. Those pilots described in precise detail what the Zero could do and what it could not. On April 22, 1942, Lieutenant Commander Butch O'Hare, already a Medal of Honor recipient for single-handedly attacking a formation of 9 Japanese bombers over the Lexington, visited the Grumman factory at Bethpage. He sat with Hall, Schwendler, and the engineering team and analyzed the Wildcat's performance against the Zero in combat. He told them where the Wildcat fell short. He told them what the Zero could do that no American fighter could match, and he told them what the Zero could not do. It could not take a hit. It could not dive without risking structural failure. It could not roll quickly at high speed. Every weakness O'Hare described was a specification the Hellcat would be built to exploit. The Navy's Bureau of Aeronautics directed Grumman to raise the cockpit higher for better visibility. It directed Grumman to switch from the Wright R2600 engine to the more powerful Pratt & Whitney R2800 Double Wasp, producing 2,000 horsepower. Schwendler redesigned and strengthened the airframe to carry the heavier, more powerful engine. The wing was mounted lower on the fuselage. The landing gear was moved from the fuselage to the wing roots to accommodate a larger propeller. Hall integrated the changes and flew the result. The Akutan Zero confirmed what the pilots and engineers at Bethpage already knew, and the captured Zero's data allowed Grumman to make late refinements before the Hellcat entered fleet service. But the airplane existed before the Zero was recovered. It was designed from pilot reports, not from a captured enemy machine. The Hellcat that Hall flew and Schwendler structured was the philosophical opposite of the Zero. Where Horikoshi stripped weight to gain performance, Schwendler added weight to gain survivability. Where the Zero sacrificed protection for agility, the Hellcat sacrificed agility for everything else. The design philosophy was deliberate, unapologetic, and rooted in Grumman's founding principle. The machine must bring the pilot home. The F6F Hellcat weighed 12,598 LEs fully loaded. The Zero weighed roughly 6,100. The Hellcat was more than twice as heavy. It carried 212 LEs of cockpit armor. The Zero carried none. The Hellcat had self-sealing fuel tanks that could absorb multiple bullet strikes without catching fire. The Zero's fuel tanks had no protection. A single incendiary round could turn a Zero into a fireball. The Pratt & Whitney R2800 produced 2,000 horsepower. The Zero's Nakajima Sake produced 1,130, nearly double the power. The Hellcat was faster, reaching 376 altitude against the Zero's 331. It could dive at speeds that would tear the Zero apart. Its aileron roll rate at high speed was dramatically superior. Above 200 knots, the Zero's ailerons froze. The Hellcat's did not. The Hellcat carried 650 caliber M2 Browning machine guns with 400 rounds per gun. It could also carry 2 1,000 Plausible bombs or 6 rockets under its wings. The armament was not subtle. It was overwhelming. And the Hellcat could absorb punishment. Pilot after pilot reported bringing Hellcats home with holes in the fuselage, sections of wing shot away, hydraulic lines severed, and oil streaming from the cowling. Schwendler's structural philosophy, building every component to twice its required strength, paid its dividend not in the engineering specifications, but in the cockpits of damaged fighters limping home to carrier decks across the Pacific. The Hellcat was also forgiving. It was designed so that a young pilot with limited training could learn to fly it quickly, operate it from a carrier deck competently, and fight it in combat without the machine punishing his inexperience. This was not accidental. Grumman's philosophy demanded it. The Navy was training thousands of new pilots every month. Those pilots needed a fighter they could master in weeks, not months. The Hellcat gave them that. The machine did not need to outmaneuver the Zero. It needed to outfight it, outlast it, and outproduce it. Outproduction was Sweerble's department. Before the war, Grumman employed 700 people. By 1943, the Bethpage workforce had reached 25,500. Sales in 1940 totaled $4 million. By 1943, they reached $400 million, a 100-fold increase in 3 years. Sweerble ran the production floor the way he ran everything else, personally. He walked the factory. He talked to workers by name. He set up training programs for new employees, many of whom had never touched an aircraft before Pearl Harbor. Women entered the Bethpage factory by the thousands, building wings, riveting fuselages, and assembling engines. In November 1943, 3 women test pilots, Barbara Jane, Elizabeth Hooker, and Teddy Kenyon, flew Hellcats and Avengers off the Bethpage runway in front of reporters. They were believed to be the only women in the country testing military aircraft for a manufacturer. Employee turnover at Grumman during the war was half the rate of competing aircraft plants. Profit margins held at 10%, while competitors slipped to 4%. The Navy awarded Grumman the E Award for production efficiency 5 years in a row. At peak output, the Bethpage factory was building 1 Hellcat every single hour around the clock. In 1944, the Navy asked Grumman to slow production to 500 aircraft per month. Sweerble told them he could build 700. In March 1945, the factory produced 664 aircraft in a single month. Secretary of the Navy James Forrestal said publicly that Grumman saved Guadalcanal. The Hellcat was designed to be manufactured. Hall and Schwendler made deliberate engineering choices to simplify assembly, reduce unique parts, and enable workers with minimal training to build combat-ready fighters at industrial speed. The Hellcat was not just designed to win dogfights, it was designed to win a production war. And in the Pacific, the production war was the war that mattered most. By the end of the conflict, Grumman had produced 12,275 Hellcats in roughly 3 years. Rear Admiral John S. McCain said that the name Grumman on a plane had the same meaning to the Navy that sterling had on silver. The F6F Hellcat entered combat on August 31, 1943, when Hellcats from VF-5 aboard the USS Yorktown destroyed a heavily defended Japanese flying boat near Marcus Island. It was a modest debut. The first real test came over Tarawa in November 1943. Hellcat pilots reported 30 Zeros destroyed for the loss of a single F6F. For pilots who were largely new to combat, many of them having trained on the Hellcat for only weeks, the result was extraordinary. It was not the result of superior airmanship. It was the result of a machine that compensated for inexperience by being more forgiving, more durable, and more powerful than anything the enemy had. Over Rabaul in New Britain that same month, Hellcats and Corsairs fought day-long battles against concentrated Japanese opposition from multiple airfields and claimed over 50 aircraft destroyed. The reputation was established within weeks. Word spread through the fleet. The new Grumman fighter was not just an improvement over the Wildcat, it was a different category of weapon. The pattern established itself within weeks. Hellcat pilots used the tactics that combat experience and the Akutan Zero evaluations had codified: dive from altitude, use superior speed to close the gap, fire with devastating volume from 6 heavy guns, and extend away before the Zero could bring its turning advantage to bear. If the Zero tried to follow in a dive, it risked structural failure. If it climbed, the Hellcat's 2,000 horsepower engine closed the distance. If it fought at altitude, the Hellcat held every advantage. The Hellcat's greatest day came on June 19, 1944, at the Battle of the Philippine Sea. The Japanese Navy launched 4 massive carrier strikes against the American fleet. 480 Hellcats from 15 carriers rose to meet them. In the first wave, 42 of 69 Japanese aircraft were shot down. In the second, over 100 of 128 were destroyed. By the end of the day, Japanese naval aviation had lost approximately 350 aircraft. American losses were minimal. Pilots called it the Great Marianas Turkey Shoot. The name was not boastful, it was descriptive. Japanese carrier air power never recovered. The battle did not merely decide who controlled the skies over the Mariana Islands. It ended Japan's ability to conduct large-scale carrier operations for the remainder of the war. The disparity was not the Hellcat's work alone. Japanese pilot training had collapsed. The experienced aviators who had terrorized the Pacific in 1941 and 1942 were dead, killed over Guadalcanal, Rabaul, and the Solomons. Their replacements were undertrained, given fewer flying hours, and sent into combat against American pilots whose training improved every month. The Hellcat made the disparity lethal. A trained American pilot in a Hellcat against an inexperienced Japanese pilot in a Zero was not a contest. It was an execution. By war's end, the F6F Hellcat was credited with 5,163 aerial victories. Only 270 Hellcats were lost in air-to-air combat, a kill ratio of 19-1. The Hellcat accounted for 75% of all aerial victories recorded by the United States Navy in the Pacific. It produced 306 aces. The most successful was Captain David McCampbell, who shot down 34 Japanese aircraft. On October 24, 1944, during the Battle of Leyte Gulf, McCampbell and his wingman, Ensign Roy Rushing, intercepted a formation of 60 Japanese aircraft. 2 Hellcats against 60. McCampbell shot down 9. Rushing shot down 6. The formation broke. McCampbell received the Medal of Honor. The Hellcat was not the fastest fighter in the Pacific. The Corsair was faster. It was not the most advanced. The P-51 Mustang was more refined. It was never the most agile, but it was the most effective. It arrived at the right moment in the right numbers with the right capabilities, and it did the one job it was built to do. The four men who built it went separate ways after the war. Jake Swerbel managed the post-war downsizing with the same intensity he brought to the buildup, scaling Grumman down so efficiently that it was the only American aircraft manufacturer to post a profit in 1946. He died of colon cancer on June 28, 1960. He was 62 years old. The man who had run the factory floor that built 12,000 Hellcats did not live to see the company land men on the moon. William Schwendler continued to lead Grumman's engineering. He became executive vice president, then chairman of the board. His structural philosophy, build to twice the required strength, ran through every aircraft the company produced after the war, from the F-9F Panther to the F-14 Tomcat. He died on January 15, 1978 in Farmingdale, New York. He was 73. Robert Hall rose to corporate vice president and supervised the design of Grumman's first jet fighters, the F-9F Panther and the F-9F Cougar. The man who had designed the fastest GB racers of the 1930s and the most lethal carrier fighter of the 1940s helped guide the company into the jet age. He died in 1991 at the age of 85. Leroy Grumman retired as chairman on May 19, 1966, and was named honorary chairman for life. He visited the Bethpage factory regularly until diabetes took his remaining eyesight in the early 1980s. On October 4, 1982, he died at North Shore University Hospital in Manhasset, Long Island. He was 87. He had watched the company build the lunar module that landed Neil Armstrong and Buzz Aldrin on the moon on July 20, 1969, a machine built at Bethpage by the same factory that had built the Hellcat. Grumman constructed 13 lunar modules. Every one that flew performed without failure. When the Apollo 13 service module was crippled by an explosion in 1970, the Grumman lunar module served as a lifeboat and kept the crew alive for 4 days. I had watched it build the F-14 Tomcat, a variable geometry swing-wing interceptor that defended the American fleet for 3 decades and became the most recognizable naval fighter of the Cold War. He had watched a company that started with 5 men and $64,325 in a broken-down garage become the most important naval aircraft manufacturer in American history. In 1994, 12 years after Grumman's death, Northrop Corporation acquired the company for $2.1 billion, topping a $1.9 billion offer from Martin Marietta. The new entity was named Northrop Grumman. The Bethpage factory was closed. The Long Island facilities that had produced Wildcats, Hellcats, Avengers, Tomcats, and lunar modules were shut down or converted into office complexes and residential developments. The 6,000-acre test facility at Calverton was turned into an airport. The company that had been the largest employer on Long Island for most of the Cold War, a company that had never posted a loss in any year of its 64-year existence, ceased to exist as an independent entity. The name Grumman survives inside Northrop Grumman the way a fossil survives inside rock. The outline is visible, but it is not the living thing. Jiro Horikoshi built the Zero alone, one engineer against an impossible specification, stripping weight until the machine weighed less than physics seemed to permit. The result was a sword without a guard, lethal but fragile, dominant until the enemy learned to stop fencing and start hammering. The Hellcat was not the work of one man, it was the work of 4. Grumman set the philosophy, build it strong. Swerbel gathered the intelligence from the men who were dying in Wildcats and carried their words back to the factory. Give us something that will go upstairs faster. Schwendler built the structure to twice the strength the specifications demanded because the specifications did not account for war. Hall drew the airplane and flew it first, testing every machine he designed before any other pilot sat in the cockpit. The Zero was a masterpiece of subtraction. The Hellcat was a masterpiece of addition. Armor where the Zero had none. Power where the Zero had efficiency. Weight where the Zero had grace. And the result was not elegance. The result was 19-1. 5,163 victories. 75% of every aerial kill the United States Navy recorded in the Pacific. Built at the rate of 1 per hour on Long Island by a workforce that grew from 700 to 2,500 in 3 years. The Iron Works did not build the most beautiful fighter of the Second World War. It built the one that brought the pilot home. If this story of the Iron Works and the legendary Hellcat has changed the way you look at the machines that shaped our history, please subscribe and like the channel. We are unearthing the engineering marvels and the human stories that they tried to bury in the past. Help us build the future by honoring the grit of the past. Our next historical treasure will be revealed soon.